of this sorting algorithm. Fine. See, first of all, we have discussed many sorting algorithms. All those sorting algorithms are comparison sort. Fine. Bubble, selection, merge, quick, heap, all are comparison sorts. We are going to compare the values given, and after comparing the values, either we are going to swap the values or we are not going to swap the values. Fine. But this sorting algorithm is not a comparison sort. We are not going to compare the values. Then how we are going to sort? See, we are going to sort the values according to the keys, the key value given. Fine. Or you can say the main funda in this sorting algorithm is you are going to count. See, as the name suggests, counting. So you are going to count the number of elements having distinct key values. Fine. Or you can say different key values. Now what is this key value? How we are going to count the number of elements, how we are going to sort, we are going to see this with the help of an example. So see, let us suppose you are given this array. Fine. And you are going to sort this array. See, although you can apply that any comparison sort, merge sort, quick sort, and the time complexity for that, the best time complexity would be n log n. You cannot get better than n log n. But how we can sort in linear time? You can say order of n time. Is it possible? Sometimes it is possible. See, sometimes. We are going to see the time complexity of this counting sort and how we are going to sort this. So see, here in this array, 0 is 1, 2, 3, 4 times. 1 is also repeated, 2 is also repeated, I guess 5 is also repeated, something like this. So here total number of elements are 17. Fine. And all the elements are in the range of, see, from 0 to see, minimum element is 0, maximum element, find out the maximum element in this array. Maximum element is, I guess, 7. So range is from 0 to 7. Fine. So you can say here k value is 7. So here you can say we have an array having k different elements, right? And maybe in this array values can be, duplicate values can be there. So how to sort this array? So here the situation is, first case is suppose the array name is A. All the elements in the array would be in the range of 0 to k. Fine. Or second case, maybe this elements belongs to any integer, maybe 0, negative, positive, very large integer, very small integer, something like this, with k different values. Fine. So we are going to check this case. So here for this case we are going to apply another sorting algorithm, because here values can be negative. So this counting sort we will discuss, that will not work on the negative values. Fine. So condition is here the array should contain no negative values and the values should be in the range of 0 to k. Somewhere in some numericals you are given this k value in the question only, but somewhere it is not given. So you can find out k value. You check out the maximum element in this. Maximum element is 7. Fine. So k value would be 7, right? And range would be from 0 to k. So first of all we will discuss this case. Range would be from 0 to k with the help of an example. Then we are also going to see some another variants of this counting sort. Okay. So let us take this example. This is the array. The name of the array is A. Total number of elements in this array is 17. Index is from 0 to 16. Fine. And k value is what? The range you can check out. The minimum is 0. The maximum element is 9. Fine. So range is from 0 to 9, or you can say the k value is 9. Fine. Now the first step is what? We are going to count. See, I have told you counting the elements having distinct key values. Key value means this 2, this is the key value, 1, this is the key value. Fine. How many times this 2 is there in this array? You are going to count that thing. 1, 2, 3, 4. Fine. How many times 1 is there in this array? 1, 2 and 3 times. Like this you are going to count the elements. Fine. And after counting, obviously you are going to store those elements in somewhere. So for storing that count, we are going to take another array, and I am going to take the name of the array as count. Right. Now the size of this count array would be this k plus 1. So 9 is there. See, range is from 0 to 9, so 10 elements would be there. Range, this size would be k plus 1, or you can say range plus 1. So let us suppose this array is there, another array. So index would be from 0 to 9, same as the range of this array, given array. Now we are going to count the frequency, or counting the elements having distinct key values. See, so see what should be there in this count array. The key value is 2. This 2 is how many times? 1, 2, 3, 4. So here we should have 4. See, 1. The key value is 1. 1 is how many times? 1, 2 and 3. So here 1 is there, and this is how many times? 3 times. And next 0. 0 is how many times? 1, 2, 3. 3. Like this you are going to fill this array. But now we will see how we are going to fill this array actually, how we are going to write down 4 here, how we are going to count the number of elements. Fine, how we are going to write down the code. See, first of all we are going to take one variable I. Fine, here the value is 2, right? So the value is 2. In this count array, go to the index 2. This is the index 2, and at starting the value in this count array would be 0. You are going to initialize this count array would be 0, all the values, right? Fine. Now see this 2, go to the index 2 and increment this value. Now it becomes 1. We are going to add 1. Now I would be at this place. You are going to increment this I. Now here value is 1. Now go to this index 1 and increment this value. This is now 1. Now again increment I. Value is 1. Again go to the index 1 and increment this value. We have 1, so after incrementing the value becomes 2. Now next is 0. Go to the 0th index, increment this value 1. Now next is 2. Go to the index 2, increment this value, that is 2. Next is 5. Go to the index 5, increment this value. Next is 4. Go to the 4th index, increment this value. Next is 0. Go to 0th index and increment this value 2. Next is 2. Fine. Go to index 2 and increment this value, that is 3. Next is 8. Value is 8. Fine. So go to the index 8, increment this value. Next is 7. Index 7, increment this value. Next is also 7. Go to index 7, increment this value again. Next is 9. Go to index 9, increment this value. Next is 2. Go to index 2, increment this value, that is 4. Next is 0. Go to this 0th index, increment this value. 1. Go to index 1, increment this value. Then last is 9. Go to the index 9, increment this value. Fine. This is how we are going to fill this count array. You can check out this 9 is how many times? 1 and 2. This 8 is how many times? Only 1. Fine. How we are going to write down the code for this? See, we are going to take one for loop. We are going to take one variable I would be started from 0, and I would move till here less than n, or you can say less than equal to n minus 1. N is 17 and I plus plus. Now how to fill this count array? You are going to write down code for that. You are going to increment this value, count array value. Fine. See, first of all what you have done, you have just checked this value, that is 2, and you have gone to the index 2 and then increment this value. Fine. So how we are going to access this value? Array name is A and I. This is how we are going to access the value of an array. I hope you know. Fine. Now you find 2. Now you go to this index, index 2, and name is count. Fine. Index is same, not 2 and 2. So here you will write count, because the value of this A of I is just an index of this array. So count brackets a and I, and now you will do plus plus. So here you can write plus plus, or here you can write plus plus, post increment or pre increment. In this case both will be same. This is what you have done. At starting only, when you are going to take this array, you are going to initialize this array with zeros. For I is equal to 0, I less than equal to k, and count of I is equal to 0. So now next step is, now you have counted the elements, the frequency of the elements, fine. But now you are supposed to find out the actual position of these elements in the sorted array. See, after sorting, the array would be something like this. See, after sorting array would be something like this, fine. This is unsorted array, this is sorted array, right? So this 0 would be from 0 to 2, the index would be from 0 to 2, fine. First 3 position for 0, then position for 1 is 3, 4, 5, these position 3 to 5. Position for this 2 is 6, 7, 8, 9, from index 6 to 9. This is 10, 11, 12, 13, 14, 15 and 16. For 9th, the position would be 15 and 16. Now how you will come to know that the position of 1 is from 3 to 4, from index 3 to 4? How you will come to know that the position for the 7 is? Because here, from here you can say that 7 are 2 times in this array, but what is the position in this sorted array? At index 12 and 13. So now we are going to update this count array, fine, such that this count array contains the actual position of the elements, fine. See how we are going to do that. We are going to update this array. I am going to update this count array. This is same count array, we are going to update in the same array, fine. See, first value would be as it is, the value at index 0, that would be as it is. We are going to start a loop from here only, from the first index, fine. After these 3 zeros, for next three positions 1 would be there, fine. So the position of 1 would be, see, after these 3 zeros, so 3 plus 3, that is 6, up to 6. See, index is 5 but position is 6, 1, 2, 3, 4, 5, 6, right? So here we are going to take the count, na? That is why we are going to take the 6. How we are going to find out this position 5, I am going to tell you later, fine. Now after 1 next 4 would be 2. So position of this 2 would be 6 plus 4, that is 10, till 10 here. See, index is 9 but position is 10. This is how we are going to update this array. So now next is this, for this 3, 10 plus 0, that is 10 only. 10 plus this 1, this next element, that is 11. 10 plus 1 is 12, position for 6 is 12 plus 0, that is 12. For 7 that would be 12 plus 2, that is 14. For 8, 14 plus 1, 15, 15 plus 2, 17. For 9 it is 17. So this is how now the updated count array. So now this array is going to reflect the actual position of this element in the sorted array. Now I am going to write down the code, fine. See how to update this count array. See, one for loop would be there. We are going to start the for loop from 1. So I is equal to 1, I less than equal to k value, k is 9, so I less than equal to 9 and I plus plus. Now how you are going to update this? See, we have done what? We have just taken this 3 value as it is, then 3 plus next, fine, 6, then 6 plus next 10, like this we have done. So how we are going to do this? See, this count of I would be count of I plus count of I minus 1. See, I we have started from 1, that is why count 1, here count 1, this count 1 would be 3 plus 3, that is 6, means count of I plus previous value, I minus 1, sorry, I minus 1. Fine, so this is how we are going to update this array. Now we are going to build the output array. How we are going to build this array, this output array? See, we have taken one another array, the name is suppose B, the size is same as the original array, having element 17, total element 17. How we are going to fill this array? This array would be sorted array. See, this is our original array, we are going to scan this array from right to left. From here, we are going to take one variable. Why I am going to start from here, I am going to tell you that thing also. See, first of all, suppose I am going to start from here, the value is 9, right? Key value is 9. So what you have to do in count array, you just go, see, this is our updated count array. We are going to see this array now, we are not going to see this one. So see, just go to the index 9, this is index 9, right? Value is 9, go to index 9 in count array, right? But we cannot store 9 at 17 because we don't have 17. This is the count, but we are actually working on the index, na? So first of all, we are going to decrement this by 1, 17 minus 1, that is 16. And in the output array, go to the index 16 and store this 9. This is the actual place for this 9. Fine. Now decrement I. Now I is at this place. Find out the value at this, that is 1. Now go to the index 1 in this count array. Index 1 value is 6. But we are not going to store 1 here. Why so? Because this is count value, but we are going to store at index 5. Fine. So first of all, we are going to decrement this by 1, that is 5. And now we are going to store at 5. Here we got 1. Fine. Why we have started from here? See, you can start from here, you will get sorted array. But I am going to start from here just to maintain the stability of this counting sort. Now what is that stability of sort? See, let us suppose in this case, this is 9 and this is 9. Both are same, 9 and 9. The position of this is 12. Index is 12 and index is 16. So this 9 is before this 9, right? The position is before this 9. So in sorted array, this 9 should be before this 9 only. The position of this 9 should be before this 9. That is the stability, that is the stable sort. Although we can write in the sorted array, you can write this 9 here and this 9 at this place, but the value is same. Obviously the array would be sorted, but this will not maintain the stability of the sorting algorithm. Fine, if you start from here only. That is why to maintain just the stability, I am going to start from here. Now decrement I. Now here value is 0, go to the index 0, value is 3. First decrement this value, that is 2. Now in this output array, at index 2, store 0. Next decrement I, value is 2, go to the index 2, value is 10. But first of all decrement this, that is 9, and now at 9th index store what? 2. Now again decrement, value is 9. Now see, again go to the index 9, at index 9 updated value is 16. But first of all we are going to decrement this, that is 15. And at 15th index in output array, you are going to store this 9. So see, as you can see here, this 9 is at place 15th and this 9 is at 16, and 15 is before 16, or you can say less than 16. So this is how we are going to maintain the stability. Fine. Now decrement again I, 7. Now go to the index 7. Here is 7. In the updated count sort, value is 14. First of all decrement this, that is 13, and at the index 13 now store 7. Again decrement I value, we have again 7, go to the index 7, value is 13. First of all decrement this, that is 12. Now at index 12 store 7. decrement this, that is 8. Go to the index 8, value is 15, decrement this, that is 14. At 14th, store 8. Decrement this, so the value is 2. Now go to the index 2 in this count array. At index 2, value is 9. First decrement this value, that is 8. At 8th index, now we are going to store this value 2. Decrement this I value, now 0. Go to the index 0, value is 2. Decrement this 1, we are going to store 0 here. Decrement this 1, value is 4. Go to the index 4. Here the value is 11. Decrement this first of all 10. At 10th index we are going to store 4. Now decrement this. Here the element is 5. Key value is 5. Go to the index 5. At index 5 in the count array, here the value is number is 12. Decrement this first of all, that is 11. At 11 we are going to store now 5. Fine. Again decrement I value. Now here the key value is 2. Go to the index 2. Here the value is 8. Decrement this first of all 7. Now at 7 we are going to store 2. Now go to this place. Value is 0. Go to the index 0. Here we have 1. Decrement this, that is 0. At the 0th index we are going to store 0. Again decrement I value. Here the key value is 1. Go to the index 1. Value is 5. Decrement this first of all 4. At 4 we are going to store 1. Again decrement 1. Go to this index 1. Value is 4. Decrement this, that is 3. At 3rd we are going to store 1. Now decrement this 2. Now at index 2 value is 7. See, updated value is 7. We are going to decrement this, that is 6. At 6th we are going to place this 2 now. Fine. And we are going to stop because we have reached to 0th index. Now you can see this is the sorted array. Fine. So we have taken another array, that is B. Now simply what you will do, you simply copy the content of this array, the element of this array to this array with a for loop. Now how to write down this thing into code, how to build this array. See, we have just, this is one for loop for this is for loop for this updated count, and now this for loop is for building this output array. Fine, we have started our for loop from here. Fine. So I value would be n minus 1 till I greater than equal to 0 and I minus minus. Fine. Now within this for loop what you will write? See, first of all what we have done, we are going to take this value and we are going to place this value in the sorted array after finding proper position using this count array. Fine. So take this value, how to take this value? Array name is A and A of I. See, A of I. This is how we are going to access this element. Now where to put this element? To this side what you will write? We are going to put this element in array B. But first of all you have to find out the proper index in this B. For that index what you will do? You will use count array. Fine. And in count array also for finding this index you will use this value, right? See, the value is 9. So same we are going to index 9. Fine. See. So this is how we are going to write. Count A of I. Fine. See, let us suppose A of I is 9. So count 9. Count of 9. This index. Now what we have done? Decrement this index first of all. Fine. So we will decrement this minus minus. See, first we will decrement, then we are going to store. So pre-decrement. So after decrementing, the value is what we have got? 16. Fine. Now this 16 is the index in this array B where we are going to store this value. Fine. So this is the index and name is array B. So in B array, this is the index you are going to calculate where you are going to store the value A of I. Fine. This is how you are going to build this array. So now at last one another for loop would be there just to copy the value of this array into the original array. So what you can write after this for loop, for I is equal to 0, to I is equal to less than n or less than equal to n minus 1 I plus plus. Just copy the content here. Array name is A. We are going to copy the content of B into A. This is how we are going to code this thing. Fine. This logic, these four loops you are going to write in a function, that is, you can take count sort. The name would be maybe count sort. In count sort you can pass array, or you can say the number of elements, and sometimes k value would also be passed. It is given, then you can pass the k value. Fine. Or if you will not pass the k value, here you can calculate within this function, you can calculate the k value. Just find out the maximum element from the given array, that would be the k value. Fine. And just take initializer array count. I guess you can take this one, this the size would be k plus 1, something like this. Take another array, that is b, and this b would be same as the size of original array. If n elements, then b of n, something like this. So I guess you can write down this count sort, initialize or declare this count array or b array, something like this. This is the main logic, these four loops, and just call this count sort function into main function. See, now what is the time complexity for this count sort? Time complexity would be what? See, time complexity is what? Just find out the calculations for the 4 loops given in the program. How many 4 loops? 1, 2, 3, 4. How many times the statements written within the 4 loops has been executed? How many times? See, this for loop, this statement has been executed for n times. Fine, n times, plus this for loop k times, this for loop also n times, and this for loop also from 0 to n means n times. So maybe something like this, 3n plus k, or you can say order of n plus k. This would be the time complexity, n plus k, where k is given the range, n is number of elements in the array. So if k is suppose a constant, you can say, so you can neglect this k and you can say order of n. In linear time you can sort the elements. One drawback of this count sort algorithm can be, say, this k value should be feasible. What does that mean? Let us suppose you are taking an array A and having 100 elements in the array. Here we have taken 17 only, and in that array we have 100 elements, and let us suppose k value is 10,000. Now what will happen? You are going to create a count array, and the size of this count array would be how much? From 0 to 10,000. In these locations only 100 elements would be there, only 100 elements. So many places in this count sort would be 0, 0, 0, 0, something like this. Fine. So this should not be a case. In this case, this applying of this count sort is not feasible. Fine. So the upper bound for this k should be order of n. N means number of elements in the array. Upper limit for this k would be number of elements in the, if number of elements is 100, then k can be 100. It's not like it can be 100, it can be 2n, it can be 5n, it can be 6n, something like this, but it cannot be approximately n square. Fine. So this is the bound for this k. This k should be order of n. And second drawback is this count sort will not work for negative values and floating point values. You can modify this count sort for negative values. After modification it can work. Maybe you can apply some normalization methods. Like see, minus negative values are there. So how you can normalize this, how you can modify this count sort? Just find out this minus value is 5. So just add this 5 to all the values. Minus 5 plus 5, 0, plus 5, 6, plus 5, 5, plus 5, 11, plus 5, 14 plus 5 is 6 plus 5 is 5, and here we have 0. Now this is the array. The range would be here, see, from 0 to 14 you can say. Fine. And again after sorting you can again decrement this. You can again do minus 5 from the result. So this is how you can normalize the negative values, and you can apply this count sort. But this logic directly cannot be applied on negative values and floating point values. Plus one more drawback of this count sort is what? It cannot be applied if the values are different in any range. There is no proper or specific range. See the values. Different values are there in any range. So we cannot apply count sort on this algorithm. It is better to apply now radix sort for this in such kind of example. Radix sort also use count sort. But in that case, we apply that radix sort in digits, on digits. First on this, then this, then this, and then on this. Fine. So if we apply on the digits, then you can say k value would always be from 0 to 9. Because these values would be from 0 to 9. Na? Each digit can be either 0, 1, 2 up to 9. So k values would be 0 to 9. So how we can apply this count sort in the radix sort, we will discuss in the next video, as well as I will write down a piece of code for this radix sort algorithm. Fine. So I will see you in the next video. Till then, bye bye, take care.